So after theorems, we move on to a new concept of area of triangle. Let's see how many formulas are there to find out area of a triangle. First basic formula is, we all know this is one triangle ABC which is given to us. So the formula is half into base into height. What will be the height of this triangle? Height always in geometry is the perpendicular. Okay, and that will be AD. So half into BC into AD, half into base into height. Okay, and height is always your perpendicular. First formula for area of triangle. What is the next formula? Say between the side BC and AC, the angle is theta. So the formula is half into AC into BC into sine of theta. So half into product of two sides into the sine of the angle between the two sides. Okay, let's understand this by this. Say there is a right angle triangle between the side AB and BC, the angle is 90. So how will you write? Half into BC into AB into sine of 90, right? The angle between the two sides, half into product of two sides into sine of angle between the two sides. But sine 90 is 1, so you get the formula as half into BC into AB. Okay, that's what you do, half into base into height. So it's a one and the same thing. If the angle keeps on changing, so will be the formula. Now if the altitude or the height is not given to you, only the three sides are given as A, B, C. If you don't know what is the height, then how will you find the area? You'll find the area by a formula S into square root of S into S minus A, S minus B into S minus C. Okay, where S is nothing but the semi-perimeter. Okay, what is the perimeter? Add all the three sides. A plus B plus C is the perimeter. Semi-perimeter is a half of that. So A plus B plus C divided by 2. So once you know S, yes. Once you know A, which is given to you, B and C, you can find the area of the triangle. So if height is not given to you, use this formula to find out the area of triangle. Now let's say in circle. What is an in circle? Inside the triangle, okay, touching the three sides. If in circle is given to, how will you find area by in circle? Area of a triangle is R into S. Okay, where S is nothing but again the semi-perimeter. Okay, so if you know the three sides, if you know the in radius of a triangle, then again you can find the area of a triangle. Okay, so know this formula. Then a circumcircle touching the outer three vertices, it will have a circumradius which is nothing but capital R. So the area of a triangle is given as A into B into C upon 4R. Okay, where R is nothing but your circumradius. So remember this 5 formula for area of triangle. Depending upon the situation, you will have to use 1 or 2 or 3 formulas in one problem. Okay, but remember all of them, the situations for them are different. Let's apply application of area of triangle. So I am being given here a regular hexagon. We have studied what is a regular hexagon. We'll study this in quadrilateral as well. Quadrilateral and polygons, all the sides are equal, all the angles are equal. So angle is 120, side is 2. Inside that I draw a circle which is an in circle. The question here is, what is the in radius of this circle? So if I draw a circle like this, what is the in radius? So we had done this earlier. Just draw a perpendicular from here. If I draw a perpendicular from here, I know this angle is 90. But I know what? If I make a triangle out of it, ABC, AB is equals to AC. Why? Because both the sides are same. So angle B has to be equal to angle C. But angle B plus angle C is 60. So angle B is 30 and angle C is 30 because that was 120. So this forms a 30, 60, 90. Okay, I know the hypotenuse, side opposite to 30, half of that is 1. Okay, and side opposite to 60 will be what? 60 will be, just multiply this by root 3. Okay, I think it's, yes, this, just multiply this by this. Yeah, so it will be, so it's wrongly written here. It has to be what now? If you can correct, if it has to be what here? Root 3, right? What will it be? It will be root 3. Why? Because you know the side opposite to 60 will be multiplied this by root 3. So I know BC is equals to root 3. Now what is the area of a triangle? Half into base into height. So I'll write this as what? Half into BC. BC is what? Root 3 plus root 3 is 2 root 3. Okay, into AD. AD, which is height, is equals to 1. So 2 gets cancelled. I get my answer as what? Root 3. This is what? Area of triangle ABC. Now what else can I do with this? Is there any other formula by which I can get the in radius? Yes, I have a formula, area of triangle ABC. Area of triangle ABC is equals to what? R into S. Okay, we just studied earlier. So I can write this as what? I can write this as R into s is equals to what? Square root of 3. What do I know from this? I know s. How do I know s? Because I know 3 sides. I know 3 sides, right? One is 2, okay, other is 2, and one is what? 2 root 3. So if I know 3 sides, I will be knowing s. From that I can find out what is r. So let's go for this. So I'll write this as r into s. S will be equal to what? Sum 2 plus 2, 4. 4 plus 2 root 3 divided by 2. That will be my s. That is equals to what? Root 3. Now take the 2 out. What will be remaining then? 2 plus root 3. 2 plus root 3 into r is equals to what? Root 3. So r is equals to what? Root 3 upon 2 plus root 3. That's it. And that is the final answer to your question. Okay. I hope you got the logic of this, because area of triangle has various formula. You just need to think which formula should be used when, and that is the most important trick in such kind of questions. Let's see few other sums on application of area of triangle. So now I get this triangle. Two triangles are here. You can see ABP and there is DBP. Okay, and what is given to me? The ratio BP is to PC, BP is to PC is 2 is to 3. I don't know the exact value, I know the ratio of it, and AP is to PD is equals to 3 is to 5. Okay, I again don't know the exact value of it. I just know the ratio AP is to PD is equals to 3 is to 5. Area of triangle ABP upon DPC is being asked. First thing that I'll notice here is angle BPA will be equal to angle DPC. How do I know that? Vertically opposite angle. Any two cross, just make an x, opposite angles will always be equal. Just make an x, opposite angles will be equal because they will be vertically opposite angle. Okay, so first thing that I know about it is this. Now what is being asked to me? Area of triangle ABP. What is area of triangle ABP? So which formula will I use? The only formula that is left is half into product of two sides, which is PB into PA into the sine of the angle between the two sides, which is nothing but theta. Now next that is I am being asked is area of triangle DPC. So let's write that. Which formula will I use? Again the same formula. Okay, which is half into product of two sides, which is what? PD into PC. Okay, into sine of angle between the two sides, which is nothing but theta. Because this is the only formula that I can use here. Okay, I cannot use half into base into height or any other formula. So what will happen if I take a ratio? Half of sine theta gets cancelled. Okay, so what am I left with right now? I'm left with this PB upon PC. Now what is PB upon PC? BP upon PC, which is nothing but 2 by 3. So write it there. Then AP upon PD, which is PA upon PD, which is what? 3 by 5. So write it there. 3 gets cancelled, answer is 2 by 5, and that is my final answer. So I'll get the answer to this is 2 by 5. You just need to know which formula of area will you use in which situation. Okay, what are the things that are being given to you? Circumradius, in radius, all three sides, height, sine of angle between the two sides. That is what you will have to think. Which formula will you use in which situation to get to the right answer? Okay, now let's see one more application of area of triangle. Now this is a brain teaser. This is one of the difficult problem that we will be solving in the entire geometry class. Okay, so let's see what is given to me. Two triangles ABC and a triangle in red, which is PQR. If you can say I had shaded this to be white. Okay, that is my triangle PQR. What else is given to me now? I am being asked what is the ratio of area of triangle PQR, which means the white part, upon area of triangle ABC. The ratio AR is to RB is given to me as 2 is to 3. The value could be anything. Multiplied by 2, 4, 6. Multiplied by 3, 6, 9. I don't know the exact value. So let it multiply by x. So 1 becomes 2x, other becomes 3x. AQ is to QC, 1 is to 1. Multiply by y, y is to y. 2 is to 3, 2z is to 3z. I just get the value out of it. Now let one angle A be alpha, B be beta, and angle C be gamma. Why am I doing this? Because now I'll apply the formula of sine theta. Now let's see what am I doing with this. Area of triangle ARQ. Imagine triangle ARQ upon area of triangle ABC. I'm comparing the area of triangle ARQ with ABC. What is area of triangle ARQ? I'll apply the sine theta formula. Product of two sides into the sine of angle between the two sides. So I will do half into one side is 2x, other side is y, into sine of angle between the two is alpha. So sine of alpha. Take area of triangle ABC half into 5x, right? If you can imagine, it's a big triangle. 5x into what? 2y, y plus y into sine alpha. Take a ratio, what will happen? I can just get there, everything gets cancelled and I get the ratio at 1:5, which means the area of triangle ARQ is 1. It's just 1 as compared to the area of triangle ABC, which is 5. Okay, so area of triangle ABC. I'm comparing ARQ with ABC. What next will I do? I'll compare BRP with ABC. If you can see, I'm eliminating all this so that I will only get PQR in the end. So what is area of triangle BRP? There's nothing but half into product of two sides, 3x into 2z, right? That is extending only till 3x and 2z into the sine of angle between the two sides, which is nothing but beta. Area of triangle ABC will be half into 3x plus 2x, 5x into 2z plus 3z, 5z into sine of beta. Everything gets cancelled, half of sine beta, x, z, z. What am I left with? 6 by 25. Which means what? If I am saying the area of triangle ABC is 25, then the area of triangle BRP will be 6. Okay, I'll have to get the common denominator now, so that the area of triangle ABC is constant over everything. Now what is left? Which triangle will I eliminate more? QPC. Then only thing that will be left is PQR. Okay, I'll subtract it in the end. So let's see, area of triangle QPC will be what? Half into product of the two sides. So y into 3z into the sine of angle between the two sides, which is nothing but gamma. So sine of gamma upon half into, if I write ABC, that will be equal to y plus y, 2y into 3 plus 2, 5z. Okay, into again sine of gamma. Everything gets cancelled and in the end I get 3 by 10, which means if the area of triangle ABC is 10, then the area of triangle QCP will be equal to 3. Comparing ABC with QCP. Now I need to get a constant number, one number which is there for ABC. So I'll subtract area of ABC from AQR, BRP and QPC, so that the only area that will be left is PQR, and that is what I want. That is what my question is asking, and that's why I did so many things. Okay, so I will compare the area of ABC. So let's take a common denominator. That could be LCM of 5, 10 and 25, 50. So to make this 50, multiply numerator and denominator by 2, so it becomes 12 by 50, which means BRP is 12, so I'll have ABC as 50. To get 50 in the first part, multiply numerator and denominator by 10 such that I get 10 by 50, which means BRP is 12, ARQ is 10, considering ABC is 50. Similarly, I'll say what? QCP is 15. That's it, subtract. ABC is 50. 50 minus 10, 12, 15. 10, 12, 15 is 37. 50 minus 37 is nothing but 13, and that will be the area of PQR. So area of PQR will be 13, considering area of ABC is 50, and that's how I get the answer to this question.